This is 1.8 composite functions. Here are your setup for your 3-column notes. Today we're going to talk about the composition of functions, which is really combining. It's a way to combine functions. It's a way to combine functions. Let's just take a look at some simple information right here. All right, for the sum of functions, you're going to look at it like this. It's f plus g, so function f plus function g of x, which is more, which could also be thought of as f of x plus g of x. And this is not new. You did this in Algebra 2. So I want you to I want you to go over to the right over here, and I want you in the 3rd column to go ahead and take this f function and g function and go ahead and add them together. I'll pause and be right here. You can pause and do that, and then I'll be right here waiting for you. Okay, next will be the difference, and that will be written as f minus g of x, which could be thought of as f of x minus g of x. Same thing, use the same 2 original equations and go ahead and subtract them. Be careful in subtraction about your negatives. I'll pause, you go ahead and work that one. Then the product, which would be fg, so f times g of x, which you could think of as f of x times g of x. And go ahead once again and pause and go ahead and work that one out. I'll be looking for this in your notes. And finally, a quotient, which would be written as f over g of x, which could be thought of as f of x over g of x. Now, be really careful here because we have a denominator, and remember you will have a restriction. So go ahead and work out your problem, but then I want x cannot equal whatever your restriction is. So make sure that you list your domain restriction. All right, we're going to go on to composites. All right, composition of 2 functions. This is just another way of combining 2 different functions. Your function rule looks like this. It's f and the little, it looks almost like a little degree symbol, g, and you read it as f of g of x. I prefer you go ahead and write it out this way. I think it helps you when you're calculating it, but it's f of g of x, and I think that will help you. We're going to work through 2 examples together, and then you'll have some in class to work on your own. So let's take a look at the f function and given g function, and we're going to find, I call it fog and golf, we're going to find f of g of x first. All right, so we're going to start inside the double parentheses, and we're going to look at the g of x function, which is this function right here. And what we're going to do is we're going to have f of 4 minus x squared. So you kind of think of you're replacing g of x with 4 minus x squared. So you have f of 4 minus x squared. Then that would mean that you're going to put all of this information in the x spot in the f function. So we would have 4 minus x squared, and then you would have the plus 2. You would simplify that and get negative x squared plus 6. And that would be your f of g. Now let's reverse that and go g of f of x. So this time, I'm going to erase up here. This time, you would take your f function, which is x plus 2, and you would think of it as g of x plus 2. And you would take that information and plug it in for the x in the second function. So you would write it as 4 minus, and then parentheses, because the x is now x plus 2, and it would be squared. You're going to use your shortcut for binomial squares. We talked about that in class already. So you would have 4 minus, and then I'm going to put this in parentheses. That would be x squared plus 4x plus 4. Distribute your negative. 4 minus x squared minus 4x minus 4. 4's would cancel, and I believe your final answer is negative x squared minus 4x. And that is the g of f. Now let's take a look at, and I'm going to ring out a room, I'm going to do it over here, the g of f of negative 2, written as, g of f of negative 2. This time we're going to plug a negative 2, erase this so you can see this better, oops. No, my eraser working, there it goes. This time you're going to plug a negative 2 into the f function, so negative 2 right there. Well, a negative 2 plus a 2 is going to give you a 0. So this whole thing will now become g of 0. And you're going to put a 0 in for that x. You would have 4 minus 0 squared, which is just going to be 4. And that would be your answer. All right, let's look at one more example and then we're done. So a short evening. Let's take a look at this example using an absolute value and a cubic. So we're going to have f of g of x. G of x is x cubed minus 2. I'm replacing f. And then g of x is x cubed minus 2. And now I'm going to put x cubed minus 2 in for the x right here in my absolute value. So it'd simply be the absolute value of x cubed minus 2. That's all we can do. So that's the first one. Let's take g of f. G of f of x. And this time f of x is the absolute value of x. And I'm going to put the absolute value of x in for this x in the g function. So the absolute value of x replaces the x, then the whole thing would be cubed minus 2, and that would be our answer. And finally, we're going to go f of g of negative 2. All right, so in my g function, I'm going to plug in a negative 2. So let's do that. So a negative 2 cubed would be negative 8, minus 2 would be negative 10. So g of negative 2 is actually negative 10. We have f of negative 10. You do not need to pause and look at this little part again if this is confusing you. Now we're going to plug negative 10 in for the x in our f function. So the absolute value of negative 10, and of course that would just be positive 10 is our output. All right, that's all I got for you tonight. I hope you have a great evening, and we will work hard in class. Look for the assignment on the board tomorrow, and I will be checking your notes. Have a great night. Night, Bearcats.